Okay, I'm a bit embarrassed to say that I have to make a correction to an earlier video that I made regarding determining the status of any given turnout and relaying that information to JMRI. In a previous video, I explained that we need to be able to tell JMRI what the status of a particular turnout is, whether it is in the closed position or in the thrown position as shown here. When we initially start up our layout and start up JMRI, unless we move a turnout, we do not know what the status is. JMRI does not know what the status is until it gets feedback from that turnout. For example, we'll take a look at a couple of turnouts that have not been hooked up with sensors. If you see this whole yard area ladder that has been set up, including the entry, even these this crossover here, this whole yard area in general has not yet been hooked up with a sensor. The very bottom down here, turnout 22 at the bottom, has been hooked up with a sensor, as has 61 over here has been hooked up with a sensor. So has 23 right here that goes off to the bottom. But you see all of these turnouts up here are still without sensors. And since I recently turned on JMRI, turned on the track power, they are all showing in an unknown state. In other words, you can't tell from the diagram which one, which way they're turned. If I were to take, for example, let's just take the crossover. If I come down with a mouse and click in the crossover position, you'll see that that causes the turnouts to change to the, in this case, closed position, not crossover, and the diagram indicates correctly only because JMRI assumes that since I clicked on that turnout, I wanted those turnouts to go to the closed position, and therefore it assumes that that's the position that they're in. JMRI really does not know where they are. It sent the signal to send them there, and in fact they are in that position. But JMRI really doesn't know that because it has no feedback. If I were to click it again, it will go to the crossover position. Again, it's showing that because it's been commanded there, and it assumes that because I told it to go there, that's where it went. Yet all of these up here are still uncommanded. But you notice that the ones that have the sensors down here at the bottom, this entrance to this other yard over here, the ones up around the Y, this crossover right up here, are all indicating that they are in a known position because they all have sensors that are connected to them. In my previous video, I suggested using the BDL168 sensors from Digitrax, and I showed how to hook that up, showing the active state of a given block of track, etc. And I showed that you could use the same system with a resistor to indicate the status of the turnout by connecting to the single pole double throw switch that is connected to the Smale or Tortoise turnout motors. This diagram shows how we connect the two types of connections for sensors, one for the track and the block detection for track, the other for monitoring of the turnout switch machine contacts. At the top of the diagram, you see that track power is connected to one side of the track. The other side of the track is connected to the opposite side of track power, but through the BDL 168, so that the engine or other resistance car, such as a lighted passenger car or a car with resistance wheel sets on them, will create a resistance across the track, thus creating a flow of current from the two sides of track power through the BDL 168, which senses that current flow and sends a signal to JMRI indicating that that track segment is occupied or active. Likewise, at the bottom, we show how the same thing is accomplished using a resistor and the single pole double throw switch located on the switch machine. The current flows from the one side of the track power through the switch, through the resistor, and through the BDL 168 section to indicate a current flow. Obviously, that only happens when the tortoise switch is thrown closed, which happens when the switch is in the thrown position. We want to connect it so that when the turnout is in the closed position, that the tortoise switch is actually open, showing that there is no current flow and that the sensor is inactive. JMRI considers active sensors to indicate a thrown turnout. My method for getting that information to JMRI was to use something called Logix, Logix, and we'll take a look at that over here in the menu of the control panel. And just to show you what I was talking about, I'll pull down the Tools menu and come down under Tools to Tables, and then, if I can move the mouse correctly, then over to Logix. And we will pull up a table that shows a set of different Logix statements that have been made. And in my previous video, I showed you how to use this system to correctly get the feedback into JMRI. As I also stated in a previous video, there are several ways to accomplish the same task. This is true with almost every computer and every program that I've ever worked with. In this case, as is typical, maybe Murphy was sitting on my shoulder at the time, but I picked the most difficult way to do it and also the one most fraught with problems, and I found some of those problems on my own layout. I've subsequently learned that there's a much better way, much easier, much less complicated, and much less fraught with errors that exist within JMRI. Unfortunately, I hadn't learned about it. I have now. So I'm going to disregard this Logix right now and show you the system that we would like to use for getting the feedback from a turnout into JMRI. Okay, the process for getting our feedback from a turnout back into JMRI to show what the status of a given turnout is, whether it is in the thrown position as shown here or in the closed position as shown by that turnout now. The thrown and closed terminology is pretty common with Digitrax, other systems, and in JMRI. For this purpose, it is very important to note that with regard to the diagram for a given turnout, and in this case we're using the turnout there at the top of this Y. In my layout, that is designated turnout number 10. Turnout number 10 in this case is a right hand turnout. And the closed or through position is, as shown here, straight. According to the diagram that JMRI uses, the thrown position would be the one that goes out to the right here. And that's determined by the type of turnout that you placed into your diagram. In this case, I placed a right-hand turnout. Now, in some cases, you may consider the direction neither thrown nor closed, as in the bottom of this Y, for example. It would be awkward to decide which one is thrown and which one is closed. But for the purposes of this discussion that we're about to have, JMRI considers the turnout as previously designated. And this particular turnout at the bottom of the Y was a right-hand turnout. So therefore, when it goes straight through and not going to the right, it is considered closed. If I change this turnout to the thrown position as determined by what we labeled the turnout when we put it in place, that's the thrown position. Why do I make this distinction? Well, in entering this information from feedback using our previously discussed BDL-168 sensors and the 15,000 ohm resistor that I mentioned and showed you how to hook up, when we hook this up, we have to be able to tell the turnout which position to use for an active sensor and which position to use for an inactive sensor. For purposes of JMRI, if you get an active signal from the sensor that you're using and have associated with any given turnout, if the signal is active, JMRI considers that to mean that the turnout is in the thrown position. Remember, thrown in this case is determined by how you designated the turnout when you put it in place. Both of these turnouts that I'm using in this Y right here were considered right-hand turnouts. So when you get an active signal on the sensor that we have associated or that we will associate with these turnouts, that means that it is in the thrown position as shown here, both for number 10 and number 20 down here, which is going to the right. The top part of the Y has a turnout that was originally designated as a left-hand turnout, and therefore it would be active, same thing, if it is shown going to the left, regardless of how you may think of it as mainline or thrown. Like with this bottom of the Y, it's difficult to call one or the other. It is totally determined by how you designated the turnout when you entered it into your track diagram in JMRI. And this one and this one were both designated as right-hand turnouts. This one was designated as a left-hand turnout. So for our purposes, it's very important to remember which is which, because as we put this information into JMRI, we are going to need to be able to tell which, whether it's active or not, which way to show the turnout position on the diagram. Okay, now what we'll do is we will go over to the main menu over here, go to Tools, and we'll open up our turnout table. So Tools, Tables, Turnouts, and we'll open our turnout menu. And in this one, we'll scroll down. Now, as in previous discussions, I have renamed the various turnouts to be the turnout number that is shown on my diagram. In this case, this turnout up here is designated as turnout 10, and logic Digitrax, they use the Digitrax L10, LT10 is the name that I gave that turnout. So wherever I refer to it in JMRI, it is called LT10. If I hadn't named it, then it would go by the system name as shown in the first column. In this case, they happen to be the same, but you could give this any name that you wanted. For example, you could give it a name of yard turnout number 1 or something that was appropriate to its specific location. Okay, so now that we have located the turnout, we will notice over here in the column to the right that there's a column called feedback. Now, this feedback is what we really want to have the turnout sensor, as we've discussed previously. The turnout sensor is going to give the feedback, and when the sensor is active, it will show the turnout as thrown, as it is here. You can see that in the line, it shows thrown. Over here under feedback, it shows thrown for LT10. So what we need to, the next thing we want to check on is to see the sensor that's associated with that. So again, we'll go up to the Tools menu, pull down Tools, go to Tables, and across to Sensors. Click on Sensors. And again, I have associated user name. I have given a name to each of the sensors that's in use at the time. There's a bunch of them I have not yet used. They're BDL168 sensors that have not yet been hooked up. So we'll come down here. You see all the block sensors, and we'll keep on going down. They're listed alphabetically. We go down, we find the turnouts, and here is turnout 10. So the sensor happens to be designated by the system as LS41. Don't worry about that. It's LocoNet sensor 41, and that's determined by the BDL168 board number and some other items that I discussed previously in working with the BDL168. But this is sensor for the turnout 10, and I labeled it that, and that's how it's referred to in JMRI. What you'll see over here under the state for turnout 10 sensor is shown as active. And so therefore, when it's active, we get a thrown position shown on the turnout diagram that we have been working with. If we change the turnout position, and we do that in a number of ways. I can do that with a throttle, talked about that earlier. I can do that with a push button on a control panel, talked about that earlier. I can do it by touching the diagram on one of my iPads, or on this screen, which happens to be touch sensitive, or I can click on this circle right here, and that will change the position of the turnout. So I just clicked it, the motor moved it to the closed position. The switch on the Smale machine that I'm using to operate this turnout could also be the switch on the Tortoise that you operate, and we've talked about that separate video. But that sensor is now telling us, as we see over here, that the turnout 10 sensor is inactive. That means that it is in the closed position. When it's active, the turnout diagram will indicate thrown. When it's inactive, the diagram will indicate closed. And that can happen no matter how you operate the turnout. If I were to walk over to the layout and push a button to change the position of that turnout, that would cause the sensor to send back an active status, and that would cause the turnout diagram to change to the closed position. From this position here at the computer, I can only just touch on that circle and cause the turnout to change and the sensor to become active, the two causing each other. Now, what's interesting is how did we get that to be associated with that turnout? You'll notice down here in the turnout table that we were working with, LT10, we come across, there's the feedback section, and there's a mode. And under mode, there's a pull-down menu. And so if we click on the pull-down menu right here, you'll see that there are a number of different possibilities. Until you change it, the default one is monitoring it. And up until you make a change, it will be monitoring. And that means it's just looking for some input from some place. In our particular process, what we want to do now is to say we are going to control this in the one sensor mode. So if I go back to monitoring, this won't change anything over here because it hasn't gotten any kind of an input to tell it to do anything differently. So we want to change this to a one sensor mode because we only have one sensor. It's either the sensor will either be active or inactive. The possibility of using two sensors is there. One would say that it is in the thrown position. One would say it's in the closed position. You're looking for a positive feedback in both cases. That's a little bit of overkill, requires two sensors, and I don't see the point in doing that. So for our purposes here, we're going to choose one sensor. Now, you can't see it, but over here in this column called Sensor 1, we get to tell it what the name of Sensor 1 is. If I were to pull this box over, there's another column that says Sensor 2. We're only going to be using one sensor, so I've kind of left the box here so that we could see both the turnout table and the sensor table at the same time. Now, you can't see probably because it's actually shown in a very light white color now, and I'll move the cursor down a little bit so that you can see this whole line now. And LT10 shows that it's a one sensor, and the name of the sensor was Turnout 10. I need to move this box over just a little bit further because there's a pull down menu associated with that Sensor 1. And if you pull down that menu, you'll see all of the possible sensors that are available to be used, including the ones that are labeled Turnout 10 in this case, or 20 for the other one that's at the bottom of the Y, etc. But in this case, we're dealing only with Turnout 10. And so we have clicked on Turnout 10. Turnout 10 actually appears here, but since it's highlighted, it's showing it very weakly on the screen, and you can't really see it until we take the blue cursor off of that line. And then you can see that Turnout 10 is now controlling this line. So once we have associated the sensor with a particular turnout, in this case LT10, and we have designated the mode to be one sensor operation, then whenever we turn on the power, whenever we set up, get the computer operating, running JMRI, and we turn on the track power, everything is set up, the sensor will transmit to JMRI that sensor is active in this case, and it will place the turnout in the thrown position. Once again, if we change the position to closed, then the sensor becomes inactive. The monitoring causes the turnout to go to show in the closed position, and that's the diagram. And that will be the case on all of our displays, our iPads, the TV monitors, everything. And this is how we update our layout to show the active position of each turnout. Now, once you have made all of these changes, it's very important before you do anything else to go up to the Panels menu item in the control panel up here and save these panels. So you come down to your Save Panels item and click on it. And I'm going to save it back to J&J Railroad 12, which is my current saving place. Periodically I update that to the next number just so that if I make too many changes and something goes wrong, I can always go back to the previous one without losing very much. But in this case, we want to save it, and once I click save, it's going to say, do you really want to overwrite what you already have? And I'm going to say yes. If you do not do this step, when you close the JMRI, quitting at the end of the day or whatever, you will lose this information that you just put in there, and it won't work the next time. But since we've saved it, next time I turn on JMRI, turn on the track power, power up the whole layout, it will come up and properly show where each of my turnouts are located. You can see here that I've got 1, 2, 3, 4, 5 turnouts that are visible right now, and all of them are being monitored in this process. And you can see that it is indicating the current status of each of those turnouts. And this solves the problem that we had without any sensing that comes from the BDL168 sensor hooked to the SPDT single pole double throw switch located on the turnout motor.